11.6, and we're going to look at our last two tests essentially, and they're called the ratio and the root test. So pretty much you're just going to use this to test whether a series is absolutely convergent or not. So the ratio test first. It's very versatile. You can use it on virtually any series you want. So for any series, if the limit of an plus 1 over an, absolute value of it, so it's positive, is equal to L, which it will be unless the answer is infinity, and L is less than 1, so if this limit is a number that's less than 1, the series is absolutely convergent. If this is greater than 1, then it's divergent, which is kind of like the ratio test, isn't it? You know, R bigger than 1, R less than 1. And if, this is the awkward part, if the limit is equal to 1, then the test is inconclusive. So basically you find a single limit. So you don't need to do things, prove it's positive, find derivatives to prove it's decreasing, you know, all those things that take up time. You only have one job to do, and that is to find the limit of this thing called an plus 1 over an. So before we get into the, you know, get caught up in the weeds here, imagine I had this series. Then an is n squared over e to the n. What will an plus 1 be? How would I get an expression for an plus 1? What would I do?
You add 1 to each n term, I assume, right?
You do. So you call it, now notice how you add it. It's not n squared plus 1, but n plus 1 squared. And here it's e to the n plus 1. Okay, let's show you another one. So I'm not doing the test for that one. I'm really just going over the algebra of what you need to be comfortable with. Maybe you'll get a series that looks like that. Now an will be 2 to the n plus 1, n cubed over n factorial. En plus 1 then is every time you see an n, replace the entire n with n plus 1. So this fella becomes 2 to the n plus 1 plus 1. N cubed becomes n plus 1 cubed, and n factorial becomes n plus 1 factorial. And very often, at least in this case, there's a little bit of tidying up you need to do. So there's my first tidying up. N plus 1 is n plus 2. Here is my next tidying up. How did I get from here to here? Because it is correct. But what did I do to get from here to here?
I would assume that the factorial, you have like n minus 1 times the like the first term and then times the lesser term of it, which in turn would have the n term.
Well, I'm not quite sure what you said may be true. If we forget about the 2 to the n plus 2 for a minute, there's n plus 1 cubed. And what I've done here is I've written what n plus 1 factorial would look like. Wouldn't you go 1 times 2 times 3 times n and then times n plus 1? Can you see that we can now cancel one of these n plus 1s? And that would leave me with an n plus 1 squared on the bottom. And it would leave me, or on the top I should say, and it would leave me 1, 2, 3 up to n, which is n factorial on the bottom. So we're going to have to do simplifications, cancellations of expressions. And that's probably where the hard part's going to be. And then once we've done what this is, we'll get a number. And if the number's 5, it diverges. If it's 0.2, it converges. And if it's equal 1, the test is inconclusive, which means we don't know if the original series converges or not, because the test basically failed us. So let's try this out. Here's a version of question 2. We're interested in that guy. So AN is that guy. AN plus 1 is that guy. Now, once you get comfortable, you probably won't be writing this down, but right now I'm doing it. So with the ratio test says we find the limit as n tends to infinity of an plus 1 over n. So in this case, it's going to be the limit as n tends to infinity of this guy divided by this guy. And the way these questions work, you tend to get ugly fraction divided by other ugly fractions. So I'm going to try and simplify that to make finding this limit a bit easier. If you think about it, isn't another way of looking at that as the top fraction divided by the bottom, right? Top fraction. And if you divide by a fraction, isn't it the same thing as multiplying by its reciprocal? So top fraction divided by the bottom fraction. That becomes top fraction multiplied by the reciprocal. And once you get comfortable, you probably won't use that rule either, right? You'll miss that line up. Now, at this point, this is kind of as good as this is going to get. What I typically do in these questions is I split it into bits and I put like with like. And one of those two is an n plus 1. There we go. So I'm just putting all the n's one above the other. I'm doing the 6 to the n plus 1s one above the other. And now I'll try and see if there's anything I can do to make things a little bit simpler. Can't really do much to this right now, but that'll come later. You've got 6 to the power of n on the top and 6 to the power of n plus 1 on the bottom. They cancel, don't they? And you're going to get a 6 left over. Is the 6 going to be left over on the top, or is the 6 that's left over going to be in the bottom? What would you get in this case?
You get it in the bottom because the bottom has the plus 1.
Right. So essentially you get a 6. You're with me so far in the algebra. Right. Now, this guy here that I've really been doing nothing with, I'm now going to do him. I'm going to find the limit of n plus 1 over n as n becomes infinite. Couldn't I do that with L'Hopital? In which case the answer would be 1. Right? Couldn't I find the answer to that by using divide top and bottom by n? In which case the answer would be 1. And so we get 1 times a 6th, which is a 6th. So we have now found the limit of this ratio, an plus 1 over an, and it ends up being 1/6. Conclusion time. Is this series absolutely convergent, divergent, or is the test inconclusive? We got the answer 1/6. Which of those three is it?
Divergent.
Oh God, I get both. Right, look again. The answer is the 6th.
The series absolutely converges.
Agreed. Isn't L? That guy there is a less than 1, absolutely convergent. So the series, that's this guy here, is absolutely convergent. And that's called the ratio test. You find the limit of this ratio, you get a number. If that number is bigger than 1, then you will say divergent. If that number is less than 1, you will say it's convergent. And if it's equal to 1, you'll be really annoyed because it means you don't know the answer because the test isn't conclusive. Okay, let's try this one. Okay. En is all these pieces. En plus 1 is that guy. So far, so good. Now, I could simplify that right now, or I can simplify it later. It really doesn't matter too much, but we're going to have to simplify it, right? Any simplification here?
N plus 1 factorial.
Correct. What happens to it? What does it change to?
N factorial.
And what happens to the n plus 1 squared?
It goes to the first power.
Correct. So that is the simplified version of the n plus 1. So now I'll do the ratio test, which is going to be the ratio of these two guys. Well, the an plus 1 guy is going to be, I'll write in red. It's going to be 3n plus 1, n plus 1 over n factorial. And on the bottom, we're going to get 3 to the n squared over n factorial. So we're going to get top guy divided by the bottom guy. Which becomes top guy multiplied by the reciprocal of this guy. From now on, do I need to write this line down, or is it okay to go from here to here and you'll know what I'm doing? Right. Good to just ignore, right. That's the last time you're going to see that line from me, unless you ask. Now, you could probably do this without rearranging the furniture, but for some people, it's just easier if things are above each other. Are you comfortable with me rearranging the 3 terms on the top and the 3 terms on the bottom so that like is above like? Now, each one has its own little, does its own little thing. If you cancel this guy with this guy, would you agree there's a 3 left on the top? And don't they do just a perfect cancel? Technically, I guess a 1's left behind. And this guy I'm leaving alone for the time being. So it's a limit as it tends to infinity of 3 lots of n plus 1 over n squared. Are you comfortable about what the thing simplified down to? 3 times that fraction. Now, if I do L'Hopital on it, differentiate, essentially, 3n plus 1s gets you 3. Differentiate that guy, you get 2 over n. If you make n infinite, you get 3 over infinity, and the answer is 0. And 0 is okay. Different tests, different things are okay. In this world, 0 is okay. Because isn't the number I got less than 1? And if you're less than 1, it means that the original series, that one there, is absolutely convergent. Any questions about that process? Okay. Next one is aversion question 4. There we go. So ratio test, the limit as n tends to infinity of an plus 1 over an. I'll do it over here. An is the original expression. An plus 1 is replace each of these n's with an n plus 1. Now, n plus 1, take away 1, gets you n. N becoming n plus 1, n becoming n plus 1, and n becoming n plus 1 cubed. Are we comfortable about the an and an plus 1 expressions? So our ratio is now going to be the limit of this guy times the reciprocal of this guy. So far, so good. Right, now I'm going to try and cut down the number of lines of working. I've already missed one line where I would have said this guy divided by that guy. Right, I've skipped that line up. Now I'm going to not rearrange the order. Okay, -1 to the n is going to cancel out most of -1 to the n minus 1. What's going to be left when you do this cancelling?
1.
What kind of 1?
-1.
-1. Okay, so we got a -1 left. Now, to green. If 2 to the n cancels with 2 to the n plus 1, which it does, what gets left behind?
2.
Top or bottom?
Top.
2 to the n on the top, 2 to the n plus 1 on the bottom.
I would go for the denominator.
The higher powered one is the one that survives. So n plus 1 is a higher power than n, so it survives. Now, if you do 5 to the n plus 1 and 5 to the n, would you agree that they cancel? And what's left in this situation?
5 in the numerator.
5 in the top. And these guys, I tend to just leave them alone for the time being. Okay. Now, since there's an absolute value around this, what's going to happen to that -1?
Poof. Disappear.
Gone. Disappears. So I'm not going to bother writing it anymore. So as numbers go, I've got 5 halves, and I have this guy. What does this fraction look like when n goes infinite? Can you just look at that and tell me the answer? Because you should be able to. What's going to be the limit of this fraction as n goes infinite?
1.
1. Now you have to prove it, but I'm cutting corners here for time. Couldn't we do it by L'Hopital? Couldn't we FOIL out the bottom and then divide top and bottom by n cubed? But you get 1. So that means that your final answer is 5 halves. And 5 halves is greater than 1, isn't it?
So that is
So conclusion. What's your conclusion? The limit is 5.
Diverges.
It diverges. So series diverges. So we're doing a heavy duty, algebra, cancelling, making things look pretty. And then we're finished with a L'Hopital or a divide top and bottom by n cubed, whatever the method requires, to finally get a number. You will get a number out of this. Just guaranteed. It's going to happen.
Professor,
Yes.
I was wondering, why did the 2n and the 2 to the n plus 1, why did they cancel out?
Okay. So we have a 2 to the n on the top and 2 to the n plus 1. If you think about how you write 2 to the n down, it's 2 times 2 times 2 times 2, and there's n terms all multiplied together. Great. Now 2 to the n plus 1 would be 2 times 2 times 2 times 2 times 1 extra 1, because there's n plus 1 terms.
Oh, I see that now. Yeah, sorry, I thought both the 2's canceled, but
Not the 2's that so much cancel as the powers.
okay, got it.
And they interact is probably a
makes
better
sense.
word than cancel.
Okay, I get
So
it.
can you see there's a 1 on the top and a 2 in the bottom?
Yeah, all right, yeah, thank you.
Okay. I like questions, so that's good. Too easy. Like this one. This is a version of question 6. And we're interested in, for some reason, they're using K, but that's okay. You can make that n equals 1 to infinity with lots of n's. You can do k equals 1 to infinity with lots of k's. Actually, you could do any letter of the alphabet, couldn't you? Couldn't you say b equals 1 to infinity and make everything here a b, right? So the lettering is not really that strategic. So let's see if we can miss some more lines. I'm not going to miss that line because that there basically is telling everybody what test I'm using. So it's now going to be the limit as k tends to infinity. In this case, we don't have a fraction, so life gets a little bit easier. But the k plus 1 is that guy there and that guy there, are now going to be k plus 1s. So it's 4 lots of k plus 1 e to the negative, and make sure that there's brackets round. And on the bottom, 4k e to the negative k. Now, if I break this into 3 separate pieces, I have a 4 over a 4. I have a k plus 1 over a k, and I have an e to the negative k minus 1 over e to the negative k. So basically I've distributed that negative. Now each one of them is going to contribute to the answer. We just have to figure out what you get. Well, let's take the easy one. Isn't 4 over 4 going to get me 1? What would happen as k becomes infinite for k plus 1 over k? What number does that get you?
1.
1 again. You can do that by L'Hopital if you want. Now this guy here is an algebra issue. I have e to the negative k minus 1 on the top, cancelling at least partly with e to the negative k on the bottom. So what on earth do you get when you do this guy and that guy?
1 over e.
Well done. And you are totally correct. I'm just going to call it e to the negative 1, but 1 over e is perfectly correct. So the whole answer is 1 over e. And 1 over e is a number which is less than 1. So that makes the series absolutely convergent. Hopefully, the more of these guys that I do, the more comfortable you get with the ratio test. You see, there is a kind of flow. You kind of do similar things each time. You have to be a little bit careful about algebra, but apart from that, you know, what you see is what you get. This is question 8. We're back to the ends. So we're going to find the limit as n tends to infinity of en plus 1 over an. N plus 1, that guy and that guy get replaced by n plus 1. Times the reciprocal of this guy. So we're at that line. Are you comfortable with where we are right now? N plus 1, this guy, times reciprocal. Right? Now, breaking into its pieces, we have an n plus 1 factorial over an n factorial. And we have a 100 to the n over a 100 to the n plus 1. Okay, let's simplify the factorial. N plus 1 factorial on the top, n factorial on the bottom. A lot of cancelling happens with that particular combination. What is left?
Would it be n plus 1 factorial on the top?
Not the factorial.
Would it be just n plus
Plus n plus
plus 1?
plus 1. Let's show you how that works. We've really only met factorials a little while ago. Right. If someone asked you to write down what that would look like in its long format, it would be 1 times 2 times 3, and you would definitely finish at n plus 1. But the trick is to realise what the guy before the n plus 1 would be. Wouldn't the one just before it be n? And if you need it, thankfully we don't, but wouldn't the next one here be n minus 1, and then n minus 2 if you needed to do it? N factorial, on the other hand, is 1 times 2 times 3, and this time I'm quite happy just to finish it in. Do you see a 1-for-1 cancel with one exception? And the one exception is this n plus 1, and it's on the top. So we get an n plus 1 on the top. This one hopefully is a little easier. 100 to the power of n over 100 to the power of n plus 1. What does that cancel down to?
1 over 100.
Agreed. Now, if you brute force it now, what you're going to get is infinity plus 1 times 100th. Would you agree that that is infinite? Add 1 to infinity, it's infinity. Divide infinity by 100, it's still infinite. And that is bigger than 1. I guess you could say, without exaggeration, it's a lot bigger than 1. But because it's bigger than 1, the ratio test says the series diverges. Now, I know it's a fair amount of work, but would you agree it's a lot less work than the integral test would be, or the limit comparison test, or, you know, even the alternating series test, right? That you still have to prove a lot of things in that. Here, you only need to find what this ratio is, right? And if it's a number, which it will be, I guess infinity is, well, whatever, right? We'll call infinity a number, right? It's going to be something. How about that? And if the something is less than 1, it converges. If the something is bigger than 1, it diverges. We haven't had an inconclusive yet, right? So I guess I should show you one. I don't like inconclusives because what that means is we don't know. It might converge, it might not. The test is inconclusive, just means the test isn't working. Actually, see if this wasn't here, wouldn't we probably be doing the ratio test for everything? Yeah, instead of having an alternating series, I would use this. Instead of doing an integral test, oh God, yes, I'd definitely be using this, right? But unfortunately, there are going to be a lot of examples where L equals 1, and which means this test doesn't tell us anything. So I'm now going to find one. And if I can't find one, I can make one up. Okay, I'll make one up. And I'm picking a really simple one. Isn't that a P series? P equals 2, which is greater than 1. Doesn't that converge? Right. I'm going to do the ratio test on it. You might think that something as simple as that would work with the ratio test, right? Oh, the ratio test will find that right away. Well, let's see why that is wrong. It's 1 over n plus 1 squared times the reciprocal of the other one, right? So that is an, and in an plus 1, and that's the reciprocal of an. We are now looking at the limit as n tends to infinity of n squared over n plus 1 squared. Are you comfortable with the process so far? An plus 1 times the reciprocal an. Multiply the top together, FOIL at the bottom. Can I just say that if you use L'Hopital a couple of times, you'll get 1. or if you divide the top and bottom by n squared, you'll get 1. But would you agree that the limit is 1? There's a couple of lines missing, and that is inconclusive. Which means I don't know, using the ratio test, whether that converges or not. I happen to know using one of the other tests that we've got, the P-series test in this case. I'm not doing this one, but see if you did that one using the ratio test, it would also be inconclusive. So can you see, you could have inconclusive and it converges, or you could have inconclusive and it diverges. Inconclusive just means we don't know. And for all those situations where the limit is 1, that's why we need all the other tests. Integral test, P-series test, alternating series test, you know, whatever the test happens to be, we kind of need it. And so there is a lot of tests because of that. Okay, let's add something else into the mix. Here is a version of question 9. Okay. Ratio test. This 2 is from this series, but the n is replaced by n plus 1. So this is the original, right? This is the en guy. The en plus 1 guy is going to be 2 to the power of 2 lots of n plus 1 plus 1. This is 2 to the 2n plus 3. Are you comfortable where the 2 to the 2n plus 3 is coming from? It's 2 lots of n plus 1 plus 1. It's not 2n plus 2, right? You don't just, oh, I'll just add that 1. Doesn't that 2 there make a difference? So when I put 2n plus 3 here, that's why. Okay. 2 to the 2n plus 3 will cancel with 2 to the 2n plus 1. So 2 to the 2n plus 3 cancels with 2 to the 2n plus 1. What's left and where does it go?
I would assume that is 1/2 squared, which is 4. Because
You said 1 over. Do you want to revisit that answer?
oh, hold on. I think I might have been missing something. Oh wait, no. That should be 2 squared because
Yeah.
the top and bottom, the 2n cancel out, and the 3 and the 1 we can actually divide it.
Okay, correct. If you have to do 2 over something divided by 2 over something else, the rule is top power subtract bottom. In this case, the top power is that, and the bottom power is that. And if you take that and subtract 2n and subtract the 1, do you see how you get 2 squared left over? So not 1 over 2 squared. If the answer was 1 over 2 squared, you could get it. Can you imagine we switch places, put that on the top and that on the bottom? Then it would be 2 to the top power. Take away, oh, shoot and spice, one of these shouldn't be here. There we go. Take away the bottom power. So that'd be 2n, take away 1, take away 2n, take away 3, and you get 2 to the negative 2, which is 1 over 2 squared. So top power, subtract bottom power. Maybe that'll help you get it. So we got 2 squared out of that. E to the n plus 1, they cancel. What do you get left over and where does it go, top or bottom?
1 over e.
Okay, so put it on the bottom. That works for me. And the other guy, I'll just put him in right now. Can't we find this guy using L'Hopital? Won't that be 1 then? So your answer ends up being 4 over e. And if you do 4 over e on your calculator, can you trust me that the answer is bigger than 1, so it diverges? We doing okay so far? The more we do, the better it gets. It's all heavy duty algebra. Right. Next one has got some factorials in it and something even worse. Algebraic. We have an n to the n. We haven't had to deal with that guy. So I think this one I probably should take really slow. There's the original, okay? And now n plus 1. And this fella becomes that guy. Are you so far so good? Now, this fella on the top cancels just a little bit with this fella in the bottom. So let me try and convince you why that works. N plus 1 factorial is 1 times 2 times 3 all the way to n plus 1. And I'll write down the term just before it. So that's n plus 1 factorial written out in its full format. Now, if you write n plus 1 to the power of n plus 1, don't you basically get n plus 1 times n plus 1 times n plus 1 times n plus 1, but don't you get n plus 1 terms? In other words, there's n plus 1s of these n plus 1s. Now, the only thing that can really cancel is that guy cancels out one of those guys. And what does the top look like? Well, 1 times 2 times 3 all the way up to n is called n factorial. N plus 1 times n plus 1 times n plus 1 all the way to the end. Since you've used up that last one, doesn't that now mean you've only got n of those terms? And so that becomes n plus 1 to the power of n. Are you happy about the algebra to find that? So that means an plus 1 is this guy. So an plus 1 is n factorial all over n plus 1 to the n. Now that simplification that we did is actually going to help us later. So we're going to find the limit as n tends to infinity of an plus 1 over an. So that's going to be the limit as n tends to infinity of this guy times the reciprocal of that guy. So it's going to be n factorial over n plus 1 to the power of n times n to the n over n factorial. And we got a nice little 1-for-1 cancel. What we're now left with is a horrible expression that we have to deal with. Right? Now, don't go crazy and say, well, I'll just L'Hopital it. Trust me, it is not going to end well if you try L'Hopital in that. It's not going to. Don't even go there. What I am going to do is I'm going to do some algebra. If both of these are to the power of n, can't I combine them to a single power of n? That's allowed. Now, the next line is not at all obvious, but it has to be done. What in heck have I just did there? Can anyone understand what I just did from here to here? Haven't I basically took the reciprocal, the -1 power of it, and that -1 came here, and now we've got that. And you might say, well, it's still ugly. I still don't know what this is leading to, but here we go. It's now that guy. You with me? Now, I told you two magic things once. One of them was this guy. This fella, if you can remember how I wrote it, was this. And I said, trust me, I'm a mathematician, that the limit of 1 plus a over n raised to the power of b of n was e to the power of what? Can anybody remember what it is equal to?
That e to the power ab, right?
Correct. Now, in this case, isn't a 1 and b -1, so you get e to the power of -1, and e to the power of -1 is probably better called 1 over e, and 1 over e is less than 1. Right, we got the answer. The limit is 1 over e. That is definitely less than 1. So our series, absolutely convergent. Are we good? That's a real toughen one, right? We got that one. Well, that is all the practice I have time for on what's called the ratio test. We're now going to do the root test. And the root test says this: for any series, if the limit as n tends to infinity of the nth root, technically that's an absolute value, the nth root of an is a number L, A, less than 1, it absolutely converges, greater than 1, it is divergent, and if it's equal to 1, it is inconclusive. So you might wonder how you would even want to use a test like that. So let me show you an example where the root test, also called the nth root test, is kind of designed for. Suppose you wanted to do this guy. N squared plus 1 over 5n squared plus 9 to the n. So if you ever see a series where there's a fraction to the power of n, to the power of 2n, to the power of -n, Oh, to the power of n squared, right? Things that look like that, you are going to use this test. So it's the nth root of the cell. So it's going to be the limit as n tends to infinity of the nth root of that guy to the power of n. And then something kind of magical happens. What's the nth root of something raised to the power of n? What essentially happens to these two things? The nth root of something raised to the power of n. What do those two do when they interact?
Is that like n over n, which results to 1 because there's the same number?
Yes, they essentially cancel each other out, and all you're left with is that guy. Okay, that makes sense? Nth root of something raised to the power of n. Basically, they cancel out. Isn't it a bit like taking the square root of something squared? Right, they cancel out. Now, this fella, if you do L'Hopital on it, gets you 1/5. Great. And that is less than 1. So that means the series is absolutely convergent. It was pretty quick, actually, even quicker than the ratio test, wasn't it? Let's do a version of the next one, 13. Okay. Weird power, right? In this case, 2n. That's a candidate for the root test. So we're going to do the limit as n tends to infinity of the nth root of this guy. Technically speaking, it's the absolute value of that guy. If you take the nth root of something raised to the power of 2n, what power do you get left over?
2.
Right? So far, so good. Now, technically, this absolute value is helpful, but it's only because that's a negative. So if we take care of the absolute value part by making that negative positive, we can rewrite this thing as 4n squared over n plus 1 squared, right? Which is the limit as n tends to infinity of 16n squared over n squared plus 2n plus 1. Right, I've just foiled it out. Okay, you should be able to look at that and tell me what the answer would be if I use, say, L'Hopital. What will the limit of this fraction be if I used L'Hopital?
16.
And 16 is greater than 1. Conclusion. What can I say about the series?
Series diverges.
It diverges. Cool. Nth root test. Let's bring in some magic. Here is a version 14. I'm going to find the limit as n tends to infinity of the nth root of this guy. If I know that this is positive, which I do you notice I can miss out the absolute values? Because if something's positive, its absolute value doesn't do anything. If there was a -3 here, wouldn't I probably stick some absolute values and kill it off there? So if you're wondering what happened to the absolute values, I don't need them for this question, so I'm not using them. Now this is a little bit trickier. That 3 becomes 3 to the power of 1 over n. That guy there, because 1 over 2n, what power do you get when you take the nth root of n squared?
N.
You get n. Now, if you brute force this fella, don't you get 3 over 1 to infinity, which is 3 to the power of 0, which is 1. Are you comfortable about what this guy is equal to? Right, just brute force. 3 to the 1 over infinity, 3 to the power of 0, 1. Here's our magic guy. What does this guy get you?
E to the 2 AB, which is E to the 1 times 2, which is E to 2, right?
Yep. So the answer is e squared, which is greater than 1. So the series diverges. So that series has a limit of e squared, which means it diverges. What would changing that to a negative do? Well, it would make this a negative. It would make this a negative. It would make this -2. And e to the -2, which is the same thing as 1 over e squared, isn't that less than 1? And the series absolutely converges. Can you see what the difference of a plus or a minus can do to the value of what a series is? Because in the big scheme of things, 1 plus 2 over a trillion and 1 take away 2 over a trillion, you wouldn't think would make a big difference, right? They're very similar to each other, right? 1 plus 2 over a trillion, 1 minus 2 over a trillion. Yet that difference is enough to make one of them diverge and the other converge. Okay, let's try this fella. Okay, a little bit straightforward here. Isn't this an nth root and isn't this an nth power? So don't you just get a 1-for-1 cancel, right? So a little bit easier to do. Right, I need to know what this guy does. What is the limit of this fraction? And how are you going to prove it to me?
L'Hopital it.
That's a good choice. So its limit is n tends to infinity of 4 over that guy, which if you do a little bit of algebra, that's the same thing as 4n. So the answer is infinity and it diverges. Why does it diverge? Well, infinity is definitely bigger than 1, and that's why it diverges. So do you see this test? Both of them don't care if the answer is 0, right? They don't care if the answer is infinity. Don't you get a conclusion from it? Is it the one and only thing it cares about is don't get 1? Because if you get an answer that the limit is 1, you don't know anything. As long as it ain't 1, less than means it absolutely converges. Greater than 1 means it's divergent, and you are done. Now I'll leave those ones, I think. So if I give you a series, you can use either the ratio test or the root test to figure out if it converges or not. Let's suppose I have a test or a series and I know it converges. Which is that guy. I would like to know how many terms I need to use in order to find the answer to this convergent series, say to 2 decimal places. Haven't we had that problem before, right? We know it converges, but we have to figure out, do I need 5 terms or 10 terms or 2 terms or whatever? Be good? Right, now, there is a formula for calculating the guy. Remember, the guy is called Rn, right? The remainder, the error function. And the error function in this case is En plus 1 over 1 take away the limit of En plus 1 over En. It's a really weird looking formula, but that's what it is. So I'm going to go and find out what the ratio test for this limit is, because isn't that basically this guy? Right, so if the answer's a half, this is going to be 1 take away a half, right? And this is going to be an En plus 1 guy, which is fine, we'll figure him out. So let's start by finding the limit as n tends to infinity of En plus 1 over En. So that's going to be 1, well, put in the limit first. It's going to be 1 over n plus 1, 2 to the power of n plus 1. And when you do the reciprocal, you get n, 2 to the n over 1. So you are looking at n times 2 to the n over n plus 1 times 2 to the n plus 1. Are you comfortable with the way the algebra this one worked out? Okay. If I break it into its 2 pieces, I should be able to find the limit. That's the first one. And that's the second one. 2 to the n cancels out with 2 to the n plus 1. What do you get when 2 to the n on top cancels with a 2 to the n plus 1 in the bottom?
The negative 1.
Right, 2 to the negative 1, which I'm going to call 1/2. Agreed. Would you agree that this is equal to 1 if you use L'Hopital? So the limit is a half. That's less than 1. The series is absolutely convergent. That's cool. So Rn, the remainder, is a over n plus 1 over 1 take away the limit that we just found. En plus 1 is 1 over n plus 1, 2 to the n plus 1. So that's what the top is. And on the bottom, it's 1 take away a half. So it's 1 over n plus 1, 2 to the n plus 1 over a half. Dividing by a half is like multiplying by 2. That 2 cancels one of those. And we now have our formula for Rn. It's 1 over 2n plus 1, 2 to the n. Right. Are you comfortable where that came from? En plus 1. 1 take away the limit that we just found, which is a half. 1 take away a half is also a half. multiplying by reciprocal and doing a little cancelling, we get to here. Now we want the answer correct to 2, 5, 10 decimal places. Let's say it's 2. So we need to solve for n. When is that guy, right? Equal to 0.005. That's what you do when you want to find 2 decimal places. So we are trying to solve when is that guy equal to 0.005. You with me? Now, I could do this with, the guess and check one. I'll try 3, it's too big. I'll try 2, it's too small, bingo, right? And I could do it using Desmos. And can you remember I tried it Desmos last time and it was a bit of a pig's dinner? I haven't learned from my mistake. I'm going to do it again. I'm going to use Desmos to solve that problem. So I'm putting it in right now. Here we go. And I have a little trick that I think is going to make it go smoother than it did the first time. The first function we are going to put in, I'm going to call it y equals 1 divided by, put a bracket around it, another bracket, n plus 1 times 2 to the power of x. And I believe I need just one bracket there. So that's essentially, oops, I mixed in much my letters there. That's essentially my guy. Can you see him? Now, I want it to be equal to 0.05. And remember that horrible mess that you could never find it because it was so small? Here is the fix. I'm going to go here and I'm telling the y values to be negative 0.005. And I'm going to make the other side not quite 0.005 because I want to see the answer, but 0.06. Oops, 0.06. And can you see I now have a nice intersection? You see it?
You did 0.05 instead of 0.005.
Oh, I didn't put 0.05 in. Well, that can be fixed. There we go. And here is the guy. And let's see if I can get a better one. It's 5.048, would you agree? So I now know who n is. I have to tweak it a little bit, but that's fine. Yeah, that worked pretty painlessly, didn't it? A little bit easier than guess and check. I mean, you'll eventually get it when you do guess and check, but there's something more satisfying, I think, about that. Right, it has a process to it, I guess. Well, we know that n is 5.048, great. But here's the problem. N has to be a whole number, doesn't it? You can't have 5.048 terms, agreed? What do you think n is going to be?
6.
You're going to have to call it 6. Isn't that to be sure, to be safe? So if the question said how many terms, right? You would put a 6 there, right? If it went and said, what is the answer, right? What is the answer correct to 2 decimal places? Then wouldn't we return to the original function, which is this guy? Like that guy. And wouldn't we plug in 6? So what would that look like? That guy times that guy. And no, I am not going to do that calculation, but couldn't you do it? And you get your answer. So not only do we have a test for do you converge or not, right? It's either the ratio test or we could be using the root test. Don't we also now have a formula, as weird and ugly as it looks, but don't we now have a formula that allows us to get as much accuracy for those ones that do converge? I can tell you you only need 8 terms. I can tell you if you need 800 terms. Any questions? Are we good so far? Let's do one more. So this is a version of question 18. And we're doing n equals 1 to infinity of n over 3 to the n. Okay, I can handle that. We are going to use the sum to find 7 terms. And then we're also going to find out what error you would get if you did use 7 terms. Right? So we're going to find the partial sum S7, right? That's what you get when you add up 7 of these terms. And then we are going to find the error, which is that guy, right? The value of that guy when n is 7. So a little bit different. Well, 7 terms is just basically this guy, this guy, this guy, this guy, this guy, this guy. Oh, okay, I've forgotten to change my numbers. 4, 5, okay. And finally, that guy. Oh, it's going to be a bit of a pain, but here goes. 1/3 plus 2/9 plus basically 1/9 plus 481s.
You can actually write it as 3 to the power negative power of something.
Yeah, I could. And your reason, do you think that would make my calculations easier?
Well, at least you don't need to write it as 1 over something.
Oh, true. Okay, so the next one is going to be add 5 times 3 to the power of -5. I'm always worried about powers, so I'll put a bracket around it. Plus 6 divided by 3 times. Oh no. Whoa, that was lucky. Plus 6 times 3 to the power of -6 plus 7 times 3 to the power of -7. Yeah, I agree, that's easier. Okay, what happened? One-third, good. 2/9, good. 1/9, good. 481's good. 5, 3 to the -5s. Was there anything wrong with that? There we go. That should have been a negative sum. And no, that's not right. I know the answer's not that big.
I got 0.748.
I like your answer.
I got the same.
That's what I got.
Does anybody know in that horrible mess where I went wrong?
The 7, you got 3 times -7.
Oh, there we go. Thank you. There we go. Negative 0.748, just like everyone else. And that's great. Now, if I want to find R7, it's approximately equal to, according to our formula, an plus 1 over 1 take away the limit as n tends to infinity of an plus 1 over an, right? So this bit here we would get by from the ratio test, and I'm just going to try it in my head. It's going to be 1 over 3n plus 1 over 3. It's going to be a third. So an plus 1 becomes a8. 1 take away that guy, which I've done in my head, which I believe is the third. A8 is going to be 8 over 3 to the 8, and that's going to be 2/3. So that's going to be 8 over 3 to the 8 times 3/2. And I think I could probably do that on my calculator now. So on the top, it's 24 divided by, do a little bracket and go 2 times 3 to the power of 8. And the answer that we get out of that is 0.00182 blah, 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 right? What did they want? Oh, they said the answer is 0.002. No, that'd be a 9. I got that guy. Oh, that's not good.
So what is it that you're running into?
That's not right, according to them.
What I got was -1/9.
Here?
Yeah.
Okay, so -1/9 will be add 1/9. So this will be 10/9. Okay. On the top, 8 divided by 3 to the power of 8, which is that guy, divided by 10/9. Well, it's different. Are you sure it's -1/9 there? Because it is negative there, so so this is -1/9. So yeah, it's a8 over 1 take away 1/9. When you said -1/9, I thought you meant this was -1/9. So third time lucky. That guy has always been there. This guy is now 8/9. I want 0.002 here. 8 divided by 3 to the power of 8. Divide that by 8/9.
8 to the power of 3 to the power of 8.
I did. Can you tell how tired I'm getting? Because I kind of finish every night. There, we got this guy. Right, no more guessing. Let's find out what this is equal to, because I'm pretty sure that's why I'm not getting the answer. So it's this fella, which is going to be the limit as n tends to infinity of n plus 1, 3 to the n plus 1. The reciprocal is going to be that. Those cancel and you get 3 in the bottom. And then you're going to have an n plus 1 over n. So the answer was a third. So the guy we want, Rn, is going to be an plus 1 over 1 take away the limit that we just found. So it's going to be A8 and 1 take away a third. A8 is going to be, I've wrote the guy somewhere. Has anybody got, oh, the guy, here it is. A8 is n over 3 to the n, 2/3. So it's 8 over 3 to the 8 times 3/2. So I have 8 divided by 3 to the power of 8, which is this guy. And I'm going to multiply this guy by 3/2. And I get 0.00182. And they say it's 0.002. Well, I can understand that by being 2. So I'll live with that. I think I got that the first time, didn't I? And was there something I should have known? Ah, now I know. The question says, tell me the answer in 3 decimal places. So it would have been 0.002. Does that mean my first answer was the right one after all?